Imagine you're inside of a building and maybe you're going to class or you're getting a drink with your friends at Starbucks, and you begin to realize that the walls are starting to shake a little bit. Even the floor is trembling. That, my friend, you're experiencing a systematic structural failure, which is a terrible experience to go through. And I'm not gonna lie, you're probably not gonna be wanting to go inside of buildings after experiencing something like that. So today I want to propose a list of problems and solutions which consist of design flaws, poor material selection, and construction engineering miscommunication. So I wanted to start off with the question, what technically is a systematic structural failure? Well, a systematic structural failure is when a structure is unable to withstand its loading capacity, which means that there's so much stress undergoing the bearings and the columns and making it not function at its full capability. Not only is this meant only for buildings, as many people may think, but it's also meaning structures like bridges, tunnels, dams, ships, and even airplanes. Anything that has to do with a structure and being built, this consists of that. And imagine you're flying in a plane and somehow the plane starts to fall apart. And that could lead to many tragedies and incidents that we do not want to experience or our loved ones to experience. Which leads me to my second and my third problem. So the reason I put these together is because shorthandedly they tie so much together. So it has to do with the poor material selection, and this has to do sometimes with the engineer choosing poor materials and not calculating enough, which leads back to the structural analysis part where the engineer doesn't put that much emphasis in the amount of material that he or she is putting in. But it also has to do with the engineering and construction miscommunication, what has to do a lot with the structural engineer telling the construction engineer or manager to put a certain material for a beam or for the wall design, and the construction worker simply does, or engineer simply does not want to abide to those codes that are given by the structural engineer so that they could be more cost efficient and so they could make more profit because they're spending less money on a certain material. But this shouldn't be a way to go into things, because this initially starts a problem with the safety of people. Because yes, it might function for about 10 years, but what about after those 10 years? Then there's going to be structural failures, systematic failures here and there, and then it's going to become more of a problem and cost even more money to construct another building and to use other materials. And which is why it is important for me and you to learn from these mistakes made by previous engineers, because every time that we walk into a building or any structure of any sort, for example, like I said in the beginning of this video, where you're walking into class or you're going to Starbucks, or even if you're going to a fun place like Universal Studios, and there's a structure in there and there's roller coasters in there, and all those have structural failures. And while you're having fun in those type of places, you do not want to be thinking of, oh, is this building gonna collapse? Is this roller coaster gonna collapse? No one wants to think about that while you're having fun. So it is important for us as engineers to keep the society together and create a safer place for everyone.